Okay, so now let us discuss the carrier added transfer tripping scheme. So, carrier added transfer tripping scheme, that is classified as, one is known as the underreach transfer tripping scheme and the other is known as overreach transfer tripping scheme. The underreach transfer tripping scheme, that is further subdivided into direct underreach transfer tripping scheme, permissive underreach transfer tripping scheme, carrier added distance scheme for acceleration of zone 2 and carrier added distance scheme for pre acceleration of zone 2. So, these are the main different schemes available under the carrier added transfer tripping scheme. Again, as I told you earlier that the carrier tripping scheme or carrier added transfer tripping scheme works on the principle that whenever the signal, carrier signal, that is received from the other remote end substation, and if that carrier signal is used for the tripping of the relay, then that is known as carrier tripping scheme, and under that that is classified as underreach and overreach, and in underreach there are 4 different schemes available. So, let us start with our discussion with the underreach transfer tripping scheme. Now, if I consider the underreach transfer tripping scheme, let us discuss the first scheme, that is the direct underreach transfer tripping scheme. So, let us discuss the first one, that is the direct underreach transfer trip scheme. This is the time distance characteristic of the underreach direct underreach transfer tripping scheme. So, in this scheme again there are 2 relays, that is the R1 and R2, that is used to protect the line connected between bus A and B. So, we have a line which we need to protect, that is line 1. Here we have the another 2 adjoining lines, line 2 and line 3. These 2 lines are connected between the bus A and C and between the bus B and D. So, now you can see that the zones of these 2 distance relays R1 and R2, that is set as the normal zone of the distance relay, that is the first zone of this R1 and R2, that will cover 80% of the line length. So, that is why we have shown here this, that is the 80%, and this also we have shown, that is the 80% R11 and R21. Similarly, the other 2 zones are there for R1 and R2. Now, in case of fault within the first zone of both the relays, let us say at F1, if fault occurs at F1, then this fault, that is R1 relay detects this fault in its first zone, R2 relay detects this faults in its first zone, as we have already discussed that if fault occurs within the 60% of the line region, then this fault that is detected in the first zone by the 2 distance relays located at each side of the bus. So, in this case if fault occurs at F1, then R1 and R2 both this relay detect this fault in its first zone. Now, along with these 2 distance relays, we have the another device known as FT1 and FT2. It is fault detectors 1 and fault detectors 2. So, this fault detectors 1 and 2, these 2 are nothing but basically the instantaneous overcurrent relays. So, what will happen that if fault occurs at F1, this is the control circuit of the direct underreach transfer tripping scheme. So, if fault occurs at F1, which is the first zone of both the relays R1 and R2, then what will happen? Relay R1 operates. So, this 2 contacts that closes here. Similarly, fault detector 1 at bus 1 also operates because current exceeds the predetermined limit. So, this 2 contacts also closes. Same way on the other bus station B also, the R2 relay detects the same fault at F1 in first zone. So, this 2 closes. Again the fault detector 2 also detects the fault. So, this 2 also closes, and hence the direct tripping that is initiated and retrieve auxiliary relay, that is 86 1 and 2 coil of auxiliary relay, that is energized at both the bus, and hence the direct tripping is initiated. This tripping is known as instantaneous tripping. Now, in case of remaining 20% of the line section, that means if fault occurs in this section or fault occurs in this section, then let us see how we can achieve the instantaneous tripping, which is not possible if we use the conventional distance relaying scheme. So, if fault occurs on either side of the 20%, let us say the fault occurs at F2 somewhere here, then in this case as the fault is at F2, so relay R2 detects that fault in its first zone and it operates instantaneously. So, as R2 operates, the fault detector unit at bus B that also operates. So, this closes and direct tripping command is initiated and the coil of 86.2 that is energized. At the same time, the relay R2 also gives the signal. From here you can see the signal is given through the transmitter. This transmitter, it transmits the signal at the substation A. At substation A, receiver 2 receives the signal from the substation B, and along with that we have connected RR1, which is known as the receiver relay 1. So, receiver relay receives and its coil is energized, and the contact of this receiver relay 1 RR11, that is this contact, that becomes closed, and hence from here you can see the direct tripping. As this contact closes, the coil of 86.1 at substation A is energized and further tripping is initiated, which finally opens the circuit breaker at substation A. So, you can see that if fault occurs in remaining this 20%, that is we have seen at F2, then the relay R2 energize, means R2 senses the fault and that will give signal to the breaker situated at substation B. At the same time it also gives the transfer tripping signal at other substation at substation A, and the contact of this receiver relay that closes, and hence the further tripping of the breaker at substation A that is given. In this way, if fault occurs in this remaining 20%, then we can achieve the instantaneous operation. Same way, if fault occurs somewhere here, let us say F3, right, then R1 operates instantaneously, it gives command here, and it gives directly, it energizes this coil. At the same time it gives command to the transmitter that is received at substation B by receiver 1, and hence a receiver relay coil is energized and its contact closes, and hence further tripping is initiated by energizing the coil of 86.2. So, this is how the direct under reach transfer tripping scheme works. You can see that the relay R2 shifts the transmitted signal from the guard frequency to the trip frequency, and hence instantaneous tripping is initiated at bus A after the closure of the relay contact and the receiver relay RR1. Now, the question comes, why this scheme is known as direct under reach transfer trip scheme. The scheme that is called as direct under reach transfer tripping scheme, because if fault occurs in this remaining 20%, either this or either in this region, let us say in this region F2, then what will happen, if fault occurs at F2, relay R2 gives a signal through this transmitter. So, whenever the tripping signal or carrier signal is received from substation B at substation A, the receiver relay contact directly closes, and hence no other series contact is available in series with this RR11 or on the other side in series with RR21. So, as soon as the tripping signal is available from the other substation on each side, by closing of this receiver relay contact on each side, the direct tripping is initiated, and that is why the name given direct under reach transfer tripping scheme. The name under reach is given because the first zone of the relay R1 and R2, that is going to cover 80% of the entire line length, not the full 100%, that is why the under reach name is given. In case of overreach, it covers the entire line section or beyond that. That is the main difference in under reach and overreach. So, because of this reason, this scheme is known as direct under reach transfer trip scheme. Here this scheme has certain disadvantages. Let us see. Now, when we use direct under reach transfer trip scheme, this scheme may maloperate due to the inadvertent closing of the receiver relay contact, that is the RR11 or RR21, right, on each side, and this contact closes inadvertently due to the maybe when maintenance is going on or when calibration is carried out, or maybe because of the noise initiated due to switching surges in the substation or any transient or abnormal condition. So, because of this reason the contact of the receiver relay on each side that may close wrongly, and hence in this case mal-operation of the relay that may possible. The other disadvantage is that this scheme requires the phase selection logic at each bus, bus A and bus B. So, this type of scheme cannot be used when single phase auto reclosing that is involved. So, when we want to use the single pole tripping facility, that means we want to close only that phase in which fault occurs, assuming that the other two phases are healthy, then similar type of scheme we cannot implement if we use direct underreach transfer trip scheme. So, what is the remedy? The remedy, one of the easiest remedy is we use the dual transmitter and receiver set under the direct underreach transfer trip scheme, but again as we use dual transmit set of receiver and transmitter. So, the cost of this scheme increases compared to the conventional direct underreach transfer tripping scheme. So, and hence this type of scheme that is not used. So, with this background let us discuss the next type of scheme, that is known as the second one, permissive underreach transfer tripping scheme. So, let us see what is the permissive underreach transfer tripping scheme. Now, I have shown here only the control circuit, I have not shown the time distance characteristic, because the time distance characteristic of permissive underreach transfer trip scheme that remains same as the direct underreach transfer trip scheme. So, as we have discussed, the first zone of relay R1 covers 80%, first zone of relay R2 that covers 80%. So, this will remain same in case of the permissive underreach transfer tripping scheme. The control circuit also remains more or less same. The only difference is that this is the control circuit of the direct underreach transfer tripping scheme, right. So, you can see that when we use as we have discussed this underreach transfer tripping scheme, then whatever signal is received from here, the receive coil of receiver relay 1 that is directly energized or relay 2 that is directly energized, and its contact immediately closes, and as soon as this contact closes either RR11 or RR21, direct tripping is initiated, and this may mal-operate because of noise available due to switching surges in the system. So, to avoid that what we will do, we will use the permissive underreach transfer tripping scheme. So, in the control circuit of permissive underreach transfer tripping scheme, the only difference is we have included this contact or this contact in series with the contact of receiver relay 1 and the receiver relay 1 on the substation B. So, that is the only difference. So, in this scheme whenever the carrier signal is received from the far end or the remote end, then that signal is utilized to trip the breaker after confirming that the local fault detector unit has operated. So, whenever as soon as we received the signal from the far end, whenever we received the tripping signal, tripping carrier signal from the far end, instead of directly going for tripping, it will wait for permission fault detector unit whether it has operated or not. When such type of permission is required, such type of coordination is required, the scheme, that is why it is known as permissive underreach transfer tripping scheme. So, in this scheme what will happen, the contact of this fault detector unit 1 at substation A and the contact of the fault detector unit at substation B, that is connected in series with the contact of the receiver relay 1 and receiver relay 2 contact. So, in this case as these two are connected in series, the chances of mal operation of this contact, receiver relay contact, or closing of the receiver relay contact on each side because of the noise present in the signal, that can be avoided, because we are confirming this will close only and only, means tripping is initiated only and only when local fault detector unit operates. So, now how this scheme works, in case of the internal fault somewhere here F1, what will happen, both this unit, the R1 senses this fault, fault detector 1 senses the fault. So, FD1 contact that becomes closed and the tripping is directly initiated here. Same way on this side also R2 and fault detector unit 2 both will operate and hence the tripping is given. If fault occurs in the remaining 20% of the line section, that means somewhere here or somewhere here, let us consider as a case study the fault F2, then what will happen? You can see that in this case R2 will detect this fault in the first zone. So, relay R2 operates, fault detector 2 that will also operate, the tripping is hence initiated from here and the coil of 86-2 auxiliary relay that is energized, which further gives tripping to the circuit breaker. The relay R2 at the same time also transmit the signal through this transmitter 2, that is received at substation A by receiver 2 and hence the coil of receiver relay 1 is energized and its contact closes. Now, as you can see here, we have again connected the fault detector unit contact of FD1 here. So, as soon as this contact closes, direct tripping is not initiated, it will wait for this closure of this contact and this contact will definitely close, because you can see that whenever fault occurs somewhere here in F2, fault detector unit, which is basically instantaneous overcurrent relay, that actually operates instantaneously because the current exceeds the predetermined value. So, in this way the mal-operation in case of underreach transfer tripping scheme that can be avoided compared to the direct underreach transfer tripping scheme. Now, let us discuss the third point, third section which we have discussed earlier, that is the third one, that is the carrier added distance scheme for acceleration of zone 2. So, let us discuss how this scheme works. So, in this case the carrier added distance scheme, you can see the name given, carrier added distance scheme for acceleration of zone 2. Now, see, this is very important, acceleration of zone 2, that means you can see our conventional zone 2 of distance relay, it looks like this, right, it starts from here. So, 80% of the line section that covers first under the first zone of distance relay, remaining 20% right, that is covered in the second zone. Now, acceleration of zone 2, that means we are going to accelerate this zone 2, that means we are converting this zone 2 in zone 1. So, that whatever fault that falls under this region 20% and under this region, that will be taken care by zone 1 of the distance relay itself and it operates instantaneously. So, this zone 2 and zone 2 that will be converted into zone 1 by increasing the reach of the distance relay, right, first zone reach of the distance relay on each side such that the remaining fault that falls under this region 20 and 20% that will be taken care in the first zone. Let us see how it can be done. So, this is the time distance characteristic of the carrier added distance scheme for acceleration of zone 2, right, this is time distance scheme or characteristic. Now, you can see that I have shown here the same similar diagram, time distance diagram, the only difference is the first zone I have extended almost up to the 95 or 100% of the line to be protected. So, this is the line which we need to protect. Similarly, the first zone of relay R2 that I have extended up to 100% of the line 1. So, here to protect the 20% of the section beyond the first zone, right, 20% on this side and 20% on this side, on each side, zone 2 of the distance relay, that is R1 and R2, that will be converted into zone 1, we can say the acceleration of zone 2 that is carried out. Now, in this scheme the zone 2 relay operation at local end that is considered, whereas the timer of zone 2 that is avoided to ensure the fast breaker operation. So, let us discuss how the control circuit of the carrier added distance scheme for acceleration of zone 2 works. So, now you can see that here at substation A and substation B, you can see that the control circuit is more or less similar to the permissive underreach transfer tripping scheme, right. So, here you can see the relay R1, FD1 is there, its contacts are there. The only circuit which that is included, that is this path, right, along with the another contact Z21 R1, that is this contact. Again you have the path like this, and here we have included a parallel to this receiver relay contact. We have added another contact in parallel with RR11 and similarly on this side RR21. So, here we have included one contact, right, and this contact is known as T11 R1. Now, what is this Z21 R1 and T11 R1? So, this Z21 R1 is the zone 2 contact of relay R1. So, we know that there are 3 zones of relay R1. So, first zone contact is Z11, second zone contact is Z21, third zone is Z31. Similarly, we have this Z21, that is second zone contact, it has the timer also T11 R1, that means the timer first contact of timer T1 for relay R1. So, this path we have included on each side, that is the replica on substation B also. Now, what will happen in this case, that the zone 2 timer contact, that is T11 R1, right, you can see here, that is we have connected in parallel with the contact of the receiver relay, that is RR11. So, after the once we have received the transfer trip command from this side for the remaining fault on 20% of the line. So, if fault occurs somewhere here in this region, right, 20% or in this region, that is 20%, say F2, right, and same as we have considered in earlier 2 cases, that is direct underreach and permissive underreach. So, in this case what will happen, you can see that as soon as the command is received for fault at F2 or F3, what will happen, you can see that the immediately as soon as this command is received, zone 2 contact which is available, right, which is connected here in parallel with this, that is bypassed. So, what we are doing is that as soon as the command is received from the remote side, maybe from bus A to bus B or bus A to bus B, then the zone 2 timer contact, that is bypassed by closing of RR1 contact. So, RR1 contact, that is somewhere here. So, as soon as the command is received, this coil is energized, coil of RR1 relay is energized. So, whenever the coil of receiver relay 1 is energized, this contact closes. So, whenever this contact closes here, this circuit that will flow like this. So, this contact ultimately we are bypassing. Now, what actually happened? See, whenever fault occurs in this remaining 20% of the line, let us say at F2, relay R2 sees this fault in its first zone, but relay R1 sees this fault in its second zone. But as you can see, the second zone, the circle of the second zone, if we consider more relay, that encompasses the first zone, right. So, the circle of the more relay of first zone is like this, second zone is like this, it can encompasses the first zone. So, what will happen, this contact that will be closed immediately, but no tripping is given because this is a timer contact, and this timer contact will operate once the time of the operation of second zone that will be completed, and that is from 300 millisecond to 600 millisecond, that is the timing of the second zone of distance relay. Instead of waiting for that, we have connected this timer contact in parallel with receiver relay 1 contact. So, as soon as we received the signal, there is no wait for this timer, that means this time of timer is not completed, even though this contact will closes, and hence the tripping is given directly from this for remaining fault in 20% side on each side of the line section. So, this is how the carrier added distance scheme for acceleration of zone 2 works. Now, let us see the fourth scheme, which is known as the carrier added distance scheme for pre acceleration of zone 2. Now, what is the difference? Now, in case of carrier blocking scheme, we know that we have already discussed the carrier blocking scheme that is used to prevent the instantaneous operation of zone 2, means any fault occurs on F2 remaining 20% on this side or this side. So, the zone 2 timer is pre-accelerated by connecting its contact in parallel with the contact of the receiver relay. So, if I just look at the earlier case, third one, acceleration of zone 2, and this case pre-acceleration of zone 2, there is a one difference. Here we have a separate reverse looking relay that is there at each bus. So, if I just look at the control circuit of this, then the RR1 that is energized. So, you can see that the RR1 coil that is available here. So, this coil of the receiver relay 1 that is energized, which is located based on the signal received from the remote end, that is from substation B, right. And so, relay R1 at bus A operates in zone 2 and its contact R11 Z1 that closes. So, R11 Z1 that closes. So, the contact of this relay R1, this contact that closes. Now, together with this reverse looking relay at B, you can see that here we have the, if fault occurs at F2, this reverse looking relay will look in this direction. So, this is going to sense this type of fault at F2. So, reverse looking relay senses the fault and sends a blocking signal to the bus A, which will further pick up the receiver relay and changes the contact of its receiver relay, that is RR11 status, and hence that is going to allow the zone 2 timer contact, that is the T11 Z2, this contact that is decided and that will be operated in this case. There is the only difference in previous case, that is we have the reverse looking relay available in pre-acceleration of zone 2, which is going to send the blocking signal. Whereas in the case of earlier, that is the carrier added distance scheme for acceleration of zone 2, no reverse looking relay is there. Now, you can see that the action of this relay R1 or you can say R2 in zone 2 for a fault at F2 that can be accelerated, means zone 2 that can be converted into zone 1 by different ways. So, we have to consider the operating time of the conventional relay, right, or reverse looking relay. We have to consider the operating time of receiver relay, and we have to consider the carrier transmission. What is the delay in the transmission of the signal from one bus to another bus, that also we need to consider. So, with this background, let us discuss the last scheme, that is known as overreach transfer tripping scheme. So, as I told you, in case of overreach, the first zone reach of relay R1 that will go beyond the line section. So, here this is the line to be protected. Similarly, first zone of relay R2 that will go beyond the line section. The usual setting is 120 to 150%, right, on each side. So, first this is the first zone setting of relay R1 and R2. So, whenever any fault occurs at F1, both this relay R1 and R2 will sense this fault in its first zone, and the fault detector units FD1 and FD2 that will also senses the fault, and these two contact that will close, and hence direct tripping that is initiated on each side, right. Now, how the tripping is initiated in case of the internal fault. Whenever the fault occurs at F1, it will also give signal through this transmitter, it receives, and this contact becomes closed. Similarly, whenever fault occurs at F1, this also gives the signal, it is received and this contact closes. So, the tripping is directly given through the auxiliary relay 86.1 and 86.2. Now, in case of external fault at F2, say here somewhere beyond the zone between any adjoining line section, say line section 2. So, in this case, if fault occurs at F2, then the relay R1 operates in its first zone, because that will detect this fault in its first zone, because you can see the reach of R1 that is 120%. So, R1 that is going to detect this fault in its first zone. It will also going to send a signal, right, to bus B to close the receiver relay. So, this contact that will close, but you can see that relay R2 that is not going to sense the fault. So, no further tripping is initiated at substation B. right, and as no R2 is not going to sense the fault, no signal is transmitted through transmitter 2. So, no signal is received at receiver 2 at substation A. So, this will also remain in open condition. So, even though relay R1 operates, as this is in open condition, no tripping command that is given or initiated. Therefore, the tripping is prevented at bus A or similarly at bus B through the local fault detector unit contact. So, that is important point as far as overreach transfer tripping is concerned. Overreach transfer tripping scheme is advantageous compared to underreach transfer tripping scheme, because using this you can achieve the high speed tripping of on both the side of the relays. The only disadvantage of this scheme is that if your communication channel fails, then there is a probability of maloperation in case of the fault on beyond the zone of the each side of the line section, that is F2 or F3. Otherwise, there is no disadvantage of the overreach transfer tripping scheme. So, one more disadvantage is that we know that in our country earlier we were using power line carrier communication to transmit the signal. So, if we use that, then and if we use overreach transfer tripping scheme, then this type of scheme may face a difficulty, but nowadays we are not at all utilizing the power line carrier communication for transmission of the any signal from one side to the other side. So, in this lecture we have discussed the different types of underreach and overreach transfer tripping scheme. We started our discussion with direct underreach transfer tripping scheme, then we have discussed the permissive underreach transfer tripping scheme, and then we have discussed the carrier added distance scheme for acceleration of zone 2 and pre-acceleration of zone 2, and then finally we have discussed the overreach transfer tripping scheme. So, I stop here and we will continue the next chapter in the next class. Thank you.